Hello students. So today's topic is group 14 elements. Before we start the topic, please subscribe our channel and support us. And if you like our video, please press the like button and also you can share it with your friends and fellow aspirants. So what is the general electronic configuration? That is our NS2 NP2. It is also known as carbon family. These group 14 elements. Okay. So let us discuss the physical properties, that is electronegativity first. That is carbon greater than Pb greater than Si equal to Ge equal to Sn. Now atomic radius, that is increases down the group with no exception. But in electronegativity there was exception, but in atomic radius there was no exception. Now in ionization enthalpy, that is carbon greater than silicon greater than Ge, but here we can see Sn should be greater than Pb because the ionization enthalpy decreases down the group, but here we can see Pb has more ionization enthalpy than Sn. Okay. Now next is catenation order, that is carbon has uh, the highest catenation order is, so I have written it very greater than, and then our Si, then our G. G and Sn have nearly or almost same catenation order, but Pb here does not show catenation property. Okay, chemical properties. Reactivity towards air, dioxides forming, that is CO2, SiO2, GeO2. Then after this, there is monoxides, that is SNO, that in their nature is amphoteric. CO is neutral here, and also GeO is acidic. Okay. Next is reactivity towards water. Now, C, Si, and G are unaffected by H2, but Pb here becomes inert by reacting with our water because they form a inert layer, okay, on surface of our this Pb metal. Then our melting point is carbon greater than silicon greater than G greater than Sn greater than our Pb. Now reactivity towards halogen. Now they form tetrahalides like CX4, where X is denoted as ClBr or I. Now what will be the thermal stability of the halogens? That is CX4 greater than SiX4 greater than GX4 greater than our SNX4 greater than PbX4. Now halides are sp3 hybridized, okay, and the shape will be our tetrahedral. Polarity is non-polar. Next, our allotropes of carbon. So the allotropes of carbon are, first is our diamond. Diamond has 154 picometer bond length. Okay, so 154 picometer. Bond angle will be 109.28 degree. Hybridization is, we know, sp3 hybridized, and it is joined or tetrahedrali, and this is our structure of diamond. Now let us see about graphite. Okay, graphite, it has two bond lengths. This is 141.5 picometer, and this bond length is 340 picometer. Okay, its hybridization is sp2. Now each carbon has one free electron in their p orbital, so that's why graphite is good conductor of our electricity. Okay, now let us move on the next, that is our fullerene. So this fullerene is not that important, but I am just telling you that the sooty material has C60 and C70 two forms, but most found form is C60. Now there is coal. It is a crude form of carbon. It has been formed in the nature as a result of slow decomposition of vegetable matter under temperature, pressure, and limited supply of air. Now there is another allotrope, that is called cycloallotrope of carbon. Okay, it is also called C18. Now this is the cycloallotrope of carbon, and it has 9 triple bonds. So it is frequently asked question in NEET. Okay. So next is the compounds of carbon. That is the first compound is our carbon dioxide. That is our CO2. Okay. Now here are some preparation reactions of CO2. That is CaCO3. If we heat it, then it forms CO plus Ca2. And if we burn coal or oxidize carbon, then we can also form CO2, and also CaCO3 plus 2HCl diluted. That also gives us CaCl2 plus CO2 plus our H2. Okay. Now next comes carbon monoxide. What is carbon monoxide? That this carbon monoxide has a special property, that is its binding with our Hb or hemoglobin is 200 times more than the O2. Okay. Now how this carbon monoxide is formed? That is incomplete combustion of carbon. That is 2C plus O2, 2CO. Also passing steam over coke. That is C plus H2O. It forms 423 to 1273 Kelvin. If we heat it, then it forms CO plus H2. This is also called our water gas. Now remember this sign, CO plus H2 is called water gas because it is also a frequently asked question in NEET. Then also passing air over coke, that is 2C plus O2 plus 4N2, because we are passing it with air, so N2 will be present there. So 1273 Kelvin again, and it forms our 2CO plus 4N2. Now this CO plus N2, you have to remember it also because this is called our producer gas. Okay. So next is compounds of our silicon. So first is silicon dioxide. So its structure is here. Okay. So its structure is very important. Just see and remember it. Then there are some important reactions also. That is SiO2 plus 2NaOH forms Na2SiO3 plus H2. Also there is SiO2 plus 4HF gives us SiF4 plus 2H2. What is the use of silicon dioxide? That is drying agent in chromatography. Then after this comes silicones. Now what are silicones? Silicones are a type of polymer. Okay. Now where this can be used? This can be used in the surgical and cosmetic plants. Okay. It is a polymer having this kind of structure. Okay. This monomer will be looking like this, used as a lubricant. Now next is silicates. These are the most important compounds in this chapter because there are variations of it and they ask you from this. Okay, so first is our orthosilicates, SiO4 minus 4. As you can see the structure here, so it does not share any corner. Okay, as you can see, it's not sharing any corner from the structures. Next is our pyrosilicate, that is Si2O7 minus 6. So here you can see that it is sharing a corner here. So shares one corner. So as you can see, on the basis of sharing a corner, the silicates are changing and the names are also changing. Okay, so no corner sharing is orthosilicate, one corner share is pyrosilicate. Next is our cyclic or ring silicates. As you can see that one of the silicates is sharing two corners here, and its formula is SiO3 minus 2 whole n. Now you can put numbers in this whole n. Okay, so it is sharing two corners. Now our chain silicates. Now chain silicates also, they will also share two corners here. Okay, and their sign is also same, SiO2 minus 2 whole n. Okay, if we just draw it, as you can see they are also sharing two corners, and here will be another. So this is sharing two corners, right? So next is our sheet silicates. Now this structure can be drawn because it's a 3D figure, but its sign is Si2O5 minus 2 whole 5, and it shares all the three corners present. Okay. Now this is it for our group 14 elements.